Good morning still, I guess. Hope you're all refreshed. And with that, we can just start, I guess. Does the clicker work? So, very lofty title, an interactive case study from brownfield to greenfield. And I'm here today just to give both a little bit of history and also a little bit of context at what PDO is trying to do with modernizing their surface estate. Now, I will use a lot of oil and gas terminology, and if there's any questions, please make this as interactive as possible. You can raise your hand, you can ask any questions you want, so feel free to go ahead and ask any questions. I also want to cover some of the lessons we've learned over the years, and my background is that I spent a significant part of my beginning of my career abroad in Europe, where I saw legacy to next generation projects being rolled out, and I was a part of those in Shell and downstream. So as we see legacy estates here, and when I mean a legacy, older infrastructure being updated and being modernized in PDO, some of the lessons we've learned and how we've tried to phase out older infrastructure is something that I'm very passionate about in terms of the return on investment. So a little bit about my background, 15 years overall, doing mostly IT delivery projects, but very closely aligned on the business interface. So I started in downstream, which means retail sites. It was very customer facing, and I ended up at the well, so from the wheel to the well in reverse. And it's been a journey for me. And on top of that, I've lived outside of the country for about 30 years, so hence my American accent, American international schools, so they beat that into me. The other thing is, if you have any questions with regards to my source material towards the end of this, I'll give you contact details on how you can get in touch with me. So for those who are maybe visiting from the region or outside the country, everybody pretty much knows our national oil company, our beloved national oil company, PDO. It's a joint venture. It's predominantly government-owned, and our major partner is obviously Royal Dutch Shell International. We're celebrating our 50th year of production, 80th year of being a legal entity, and we have some, I should say, significant metrics that we deliver. Just under 200 fields, and we also have about 10,000 wells. About 7,500 of those are producing wells. That means the remainder are injector wells or other types of wells that are assisting in the production. We're very geographically diverse in Oman, so that means our technology and our network has to be resilient enough to be able to cover that large geography. And as time has been progressing over the last 20 years since the mid-90s, our infrastructure has become more internet-facing. And hence, we are going to talk a little bit about the IoT of things with regards to that. Can we play the first video, please?
PDO operates more than 7,000 wells, spread over a huge geographical area. The complex task of providing the information to remotely operate these wells is performed by the Real-Time Operations Team, RTO. Staff on the coast and in the field collaborate to analyze well performance issues that have been automatically detected by the RTO systems. We call this exception-based surveillance. In this example, an ESP well is operating in upthrust condition, potentially damaging for the pump. The decision is to reduce the speed of the pump and plan for a replacement. Once the replacement pump is installed at the well site, the supervisor in NIMA gathers the details and enters them into the RTO portal, the well name, the artificial lift type, and other specifics of the equipment. From this, the RTO systems can determine what data is available and how to retrieve it. A SmartField's Assist Desk agent reviews the request and, if all is OK, hits the Add Well button. This automatically configures the well in the RTO systems. a process that used to require several days of manual effort and was extremely error-prone. The first application built is the data collection layer, called OPC, which communicates with the wells over the broadband radio network, gathering all the data necessary to operate our wells. Having gathered the data, it makes it available to several other applications, such as the well management system. LOIS provides the real-time control, surveillance and optimization of our wells. It can start or stop wells remotely, change the speed, and detect well performance changes in real time. It has a virtual model of each well which calculates the theoretical well performance every few minutes, dramatically faster than the monthly well test or the annual well review. PDO have also built analytical pattern recognition for ESP wells to detect broken motor shaft, increase in reservoir pressure, etc. Using the lean approach to ESP operations with LOIS has delivered tremendous value for PDO, with almost 4,000 BOPD gained in less than 9 months.
It's enabling us to detect the problems as soon as they start to develop and to guide these people outside to go exactly where they need to go and what exactly they need to do. So we can just shut it down, let's say a number of 50 wells, just pressing over one button only, and we can have all the system down.
If you're a doctor, you need an MRI and you need a test, yeah? So LOIS for me is like a MRI for me.
They're like a specialized tool for in well analysis and well diagnosis. Tool will give you the full information about the subsurface well performance. Based on that, you can decide what sort of optimization need to be done.
Another user of the OPC data is the Corporate Data Historian, PI, which has been storing data since 2001 and now contains data for 1.1 million measurements that are collected every minute. This adds up to more than 1 billion values every day. Truly big data. This wealth of data will provide the foundation of real-time analytics as PDO move into the arena of predictive and prescriptive analytics using data mining, neural networks, and other machine learning techniques. At the top level, the RTO portal NIBRAS is the user interface, the visualization and workflow management layer. Easily accessed, this puts the information at the fingertips of anyone using a PDO desktop.
So we use NIBRAS every day, so there is standardized the way we manage our wells, we optimize our wells, we also detect failures a lot faster.
The journey of the data is complete, from its origin at a downhole sensor through the complex distributed network of components, its conversion in data modeling and analytics, to final presentation as the information needed to make informed decisions about how to optimize the performance of the well. Petroleum Development Oman, proud to serve Oman.
So, actually that was made by a 100% Omani company. The oldest person in it was 32 years old, so very proud of the younger Omanis. Anyways, so that was a lot of information compressed into about 3 minutes, and we'll take now some time disassembling it from level 1 to level 3 in architecture terms. But historically, the way that with the advent of radio, internet, and satellite internet, the way that most oil and gas industries used to pass batch data was through systems that are like real-time units, which basically collect a plethora of sensor data, and that gathers up to the OPC. And since most of you in the audience, I understand, are from an IT background, you should know what OPCs are. And that basically pushes on the data to our distributed control systems and also our middleware systems like our historian plant information. So those are the typical archetype infrastructure types. That was the model that was over 1996 to 2001 was the model that was pushed and developed and tinkered with. And we had many, many iterations of it in PDO. And basically what that has led to is about 250 combinations of devices from the moment data leaves a well to the moment data arrives at our corporate headquarters in Qaram and Mina al-Fahal. So that's one of the issues when we talk about integration, coming up to it. So once again, this gives you a little bit of a more lower level view in terms of how the architecture is set up. From on our left is closer to the well management system, the historian, and that's our core systems that you find deployed at Mina al-Fahal. On the right, that shows some of the communication layer, including our WiMAX network, which PDO relies on heavily because they are parts of the Sultanate that aren't geographically covered by broadband internet yet. And there's also fiber networks too that we're a part of. We also send metering information from our partners here in Oman, which include BP and all the other partners like Oxy. Metering information basically collates all the production type data from a very high level, so total values of production from their side that we know what we're going to expect when they get shipped out from the port. So all these systems, all these networks, working with third parties, a lot of complexity. And I've had to put a bunch of crosses on a lot of things because of confidentiality and marketing reasons, and we don't want to market for third parties. But just to give you a flavor and an idea of how complex our internet-facing architecture are and our real-time units are. When it comes to real-time units, we have probably more than a dozen. When it comes to our well types, that means the wells that we produce that use different kinds of pumps, everything from that nodding historical donkey to kind of free flow wells, which are very rare nowadays, to wells that use electrical submersibles types. You can see that we have also quite a plethora of types. And then for the ones who are really interested in hardware, we have a plethora of programming logical controllers too. And then we have test units and we have transmitters on top of that, and we have gauges. So all of them side to side, and all the permutations and all the combinations mean that instead of having just a dozen or 24 scenarios in terms of data, how should I say it, data being pushed end to end, what we have is over 250 combinations of roadmaps in terms of data going from the well to Mina al-Fahal. Now, if there's ever a case for integration, and if there's ever a case for standardization, this is pretty much it. Because this basically propagates failures, errors. You've got a headache with servicing. You've got a headache with all the third-party vendors that you have to manage. You've got all these issues, and if somebody was to say, show me how you can save X amount of million riyals a year, this is the way to do it. Get rid of this. So that's part of our journey now. And I'll give you an example. In the video, there was these ladies and gentlemen sitting in the corner called Smart Field Assist agents. Basically, they get a call from somebody in the field and they say, this real-time unit or this PLC or this OPC is not sending data. It's your fault. Fix it. And obviously, there are so many variables to go through. And that gives you, that data fault tree is the fault tree that they have to go through. And they get dozens of that calls every day. And you can see the reason why they have to go through all those layers of checks is because if we had an integrated system, end-to-end, we would not have to go through this sort of gauntlet in terms of trying to demystify where a failure might happen, be it a communication failure, or a configuration failure, or a hardware failure, or a power failure. You don't know what you don't know. And an operator in the field has to cover dozens, if not hundreds of wells sometimes. And the journey between them requires, it's many miles between them, but from different fields. So now you can get a sort of a flavor and understanding of sort of the complexity of it all. And we're talking about just under 8,000 producing wells. So how do we overcome that challenge? So I have a couple of areas of personal interest. But for me, before we jump into our areas of current focus, we'll come to where our target estate is going to in terms of removing certain bits of hardware, installing certain bits of IoT, and looking for integration opportunities end to end. But one of the things that we realized is through exception-based surveillance, which is basically saying everything's working fine end to end, but there's an issue here. And using 2 or 3 parameters, we can find out it's most likely a power failure. Now, we don't know for sure. A human being needs to go check, or a system needs more data to make that decision. But, so instead of sending a service request out, before we do that, what we realized is as we were going through this journey, we were not taking advantage of the billion-plus pieces of data that PDO collects every day. That's over almost now 1.2 million pieces of measurements every minute. And we're using less than 1% of that data. And I would challenge anybody in my company if we're using more than actually 0.5% of that every day. So we've been going on a journey of trying to put some competency and capability in the staff, both the staff in the field and the staff in Mina al-Fahal, to train them up not to be Excel-based people, but to be people who understand some of the basics of advanced analytics, especially predictive and prescriptive analytics. It's a journey, and we've just started that journey, but because we're sitting on a wealth of data, and we can sift through bad quality and poor data, it gives us an opportunity to look for integration opportunities end to end. And there were a lot of names and numbers up there, but for marketing reasons, we had to remove them. But if you represent any organizations, or if you worked any with partners like we have, let's say GE or Microsoft or whoever, and I'm not plugging those companies, I'm just saying as an example, you would understand that there's a big push to take advantage of all that IoT data that's being pushed to us and we haven't touched in the past. So the question becomes, why are we doing all of this? Like, why are we collecting all of this information through these complex systems? Why go through this exercise? Is it just to save money? Or is it to give the business more opportunities to make better decisions? So yeah, with regards to that, we have, as I will say one last time right now, and I'll stop beating the dead horse about all those complex systems. And a few weeks ago, my friends and I in the office, we just got up on the whiteboard. We started scratching around. If we wanted to do integration right, where are the choke points? You know, where are the bits that are causing complexity? And we realized, well, we could take rid of this layer, but then we need that layer. We get rid of this layer, and then we need that layer. And as I mentioned earlier, this has been developed over 20 years. So we come into these challenges with regards to analog systems and TCP/IP systems, having to have adapters and modulators put into place. And that's a level of CapEx, capital expenditure that with a $50 barrel, a company does not want to do that at this stage, especially in the GCC, especially in the oil and gas industry. We're talking about hundreds of millions of dollars of expenditure over the next decade. Does your company or organization who's developed systems over 20 years, let's say a major hospital or major power plant, do they have the appetite to go back and reinvest that kind of IoT infrastructure? Because that's a question you need to really ask yourself, what's the value of it all? So here's our target, and we're already well on the way. First target is to start using unified architecture, so OPC UA. That's pretty much agreed upon across the industry. I think that conversation about using platforms that are unified, at least on the communication layer or the protocol layer, is, I think, open and closed right now. So historical systems with proprietary systems on the way out. We're going to start using UA across all the IoT type systems. we'll put a middle layer of a sort of IoT gateway, and the reason why we need to do that is we won't be able to change the PLCs and the RTUs, and that's sort of where we're going right now. And even though I would love to get rid of the PLCs and RTU, or give that advice at least to my boss or my boss's boss, to make that decision today, right now, because it will save money down the line. Realistically, the capital expenditure is insurmountable in terms of justification. So that's where the issue lies. And then down the line, we will get rid of the RTUs and the PLCs. So we've got rid of another layer. Eventually, and this is the dream, as we've started on this journey, is to push data to be pre-processed on site. Instead of waiting for data to come to the office space from any of these IoT systems that we're collecting the data from today, have them make the decisions on site, either through automation, integration, or optimization. The optimization comes from analytics. The integration means removing layers of hardware, and the integration also comes from having to box up multiple components that were segregated over various systems into a single component. So look for opportunities like that. And that's the discussion we're having with a lot of partners. And you know all the major partners in the industry, from the Schneiders to the Honeywells of the world. So that's where our sort of journey is proceeding to. And with that, we'll talk about another area of focus that PDO has been on a journey for the last 10 years on. We've started to realize that we want to untether our staff from their desktops. And with that, if you could play the next video. So this is the early concept.
So would you please go to the booster pump station and check on pump 402? Yes. Check on the transmitter reading.
So I think that
Yes.
I think that gives you an idea of what it is. You can play the next video. So we finally piloted and trialed this over 2 years, last 2 years, 3 years. And we have something called Smart Mobile Worker, as we're terming it now. Basically, it miniaturizes everything that's available on the desktop, SAP, our production portal called Nebras, everything that's available to a PDO worker at a desktop location. On top of that, with extra features like video
Mobile
and
can drive value across PDO's workforce.
other functionality.
Let's look at 3 examples. Ahmed, a field maintenance technician, checks his daily work schedule on his device to see which tasks on the integrated assurance activities need to be carried out. He then verifies that the corresponding permits to work have been approved. He checks the well status using mobile Nebras. Traveling to the wells, he receives the most efficient route. Turn left at the next exit. Ahmed uses video conferencing to receive assistance from an expert. Ahmed populates a mobile inspection form to record the current situation of the well. The completed report is stored in SharePoint. If other corrective maintenance is required, he would raise a work order. Checking mobile Nebras once more, He finds wells with exceptions and alarms near to him that require his attention. Ahmed could also be confronted with an uncommon complex automation problem that requires expertise, such as an external vendor's assistance. The live interaction can tackle many issues and questions in one go. Ahmed reports back to the coordinator office that he has finished the permit through the e-permit app on his intrinsically safe device. Whilst on holiday, Aisha, a member of PDO's Managing Directorate Committee, receives a phone call stating that an emergency incident has occurred and her advice is required. Aisha can find all her PDO applications from her corporate iPad. In order to fully understand the situation before acting, she reviews her secure inbox. She realizes that she will need the latest data to give an appropriate steer. Aisha accesses her operational performance dashboard. For detailed information, she enters her corporate file share to find the latest version of the incident handling procedures. She now feels briefed to direct on the next steps and joins the rest of the team in the video conference. After the meeting, she updates the incident handling procedure document on Word and posts it to her corporate file share. Aisha contacts her team through PDO live chat to inform them that she has completed the necessary updates. Before logging off, Aisha sees she has a pending leave request from one of her team members. She can directly accept his request through the SAP Approvals mobile application. Yasser, a wells engineer, is planning to visit a well. Through the mobile travel booking system, he plans his flight. The flight booked, Yasser can begin his journey by driving to Muscat Airport. Before boarding the plane to one of the interior airports, he submits his journey management details on a mobile form and requests approval. During the journey, he takes the opportunity to complete training using the Wells Learning and Simulator applications and reads the Al-Manhal digital magazine. Back on the ground, Yasser's device receives his journey manager's approval. Journey logistics also inform him of which bus to take from the airstrip to reach the interior office. From the interior office, Yasser arrives at the well with a company car. He calls to inform his journey manager through link on his device.
So this has given a lot of opportunities in terms of allowing us to cut FTE, in terms of staff numbers that are required in the field. We found that one operator can do the work of about 3 now in terms of leveraging these IoT and mobile technologies. And if we can integrate them more and miniaturize them more on mobile devices and standardize them end-to-end, it just opens up so many case studies in terms of what we can do with regards to optimizing production and cutting that entire turnaround time where decisions used to take months, weeks, and even days down to minutes. And that's all become a reality through integrating a lot of these systems. And that's not where we're stopping now. Last few years, PDO is already deploying drones to do corrosion management, and now we're going to be deploying drones in pilots to pass data in terms of being able to visually inspect wells. And also, there's a lot of case studies in terms of safety that we can do in terms of having a drone be able to go check out a well that is suspect in terms of exposure to harmful gases and other H2S, other HSE concerns like H2S gas. So those are also being piloted right now. And they're all internet facing and they're all connected through our mobile and WiMAX network. So with all of that, what are the challenges we've learned in this journey? And as we go into the next 10 years of replacing our legacy systems with more IoT systems and integrating them even further, If I was to, and this is just me 3 years back home in Muscat, and coming from London and seeing how they've done it in Europe, is you want to pick one or two strategic partners. Now, there's an argument to be made, let's add redundancy to the system and let's work with 6 vendors. I feel that adds complexity and failure to a system. There's an argument to be made, well, this cuts down on competition, or this promotes monopolies. Well, what you can do is set KPIs and critical success factors, and if those partners every 3 to 5 years fail to meet them, then, replace them out. That's just how the market should work. It's not the way it works now, but it's the way it should work. If you're serious about having integration in a complex industry, you're going to need to have strategic alliance partners. And with regards to transition from brownfield to greenfield, i.e. upgrading your systems to be more IoT and more integrated, I would say timing is key. There is a point in time where you're too late to upgrade your systems, and there's a point of time where it's too early to upgrade your systems. And only you can make that decision, knowing your industry. If you're in the health industry, you can only make a decision where you need to upgrade your appliances or your instruments. If you are in the power industry, only you know that. And that comes from 5, 10, 15, 20 plus years of business knowledge in your industry. It cannot be done in a vacuum, and it cannot be done too early or too late. You have to decide when that is. And that's just a general rule that I feel we seem to miss a lot of. So my business recommendation would be, if you are speaking to a director of an organization, if you're speaking to a senior stakeholder, you always have to remind them that decisions are not made in a vacuum. There is not one right thing to do, one wrong thing to do. You need to explain to them that everything is an opportunity cost. Everything is weighed against another decision. When you're going to invest in one IoT technology, you have to pick one based against the fact that you might not do anything, or you're going to invest in another. And what does that mean for the business? What does that mean for the government? What does that mean for the industry? How much money are you going to save? How much money are you going to return? How much time are you going to save? So these are the questions that only you can answer. But sometimes it's a very awkward question, because it means sometimes breaking what was built in the past, and sometimes it means going out of your way to offend stakeholders who are already spent many years developing one system. So thank you for your time. If you have any questions, please ask them now. This is how you get in touch with me. Thank you. So currently, given current economic conditions, that is the $50 barrel, I would say it would be fair to say 5 to 10 years, closer to 10 years. Yeah, it's a good question. The horizon is always hard to identify, but it comes down to budgets.